Welcome back to our unit on the nature of chemical reactions. In this third video, this is our first video on the Learning Goal 6.1b, which will cover the topic of energy in chemical reactions. In this particular lesson, we will hit up success criteria A and B for the learning goal. Speaking of those success criteria, our learning goal here is I understand the role of energy in reactions. And the two success criteria we'll look at here, I can define the terms endothermic and exothermic, and I can relate the terms endothermic and exothermic to bond formation and bond energy. So the big theme for this lesson, and really all the lessons on this particular learning goal, is this. Every single chemical reaction, every one, there's no exception to this, every single chemical reaction either releases energy or absorbs energy. There's no exception. If the reaction absorbs energy, it is considered an endothermic reaction. So just coming up with a bit of a visual model here, if this box here represents our system or the reaction that's occurring, if energy is going into that system, into the reaction, it's being absorbed, that is endothermic. You might recognize this prefix here, endo, from other science classes, in particular biology perhaps, looking at endoskeletons versus exoskeletons, where an endoskeleton is an organism that has the skeleton inside the body. That's the same prefix there. So here, energy is going into the system or inside the system. That's why we use the prefix endo. If the reaction releases energy, it is considered an exothermic reaction. So again, using a similar visual model, if our reaction or our system is releasing energy, energy is flowing out of the system, we call it exothermic. Again, that prefix exo, same one that you might have learned in biology or some other science class, like an exoskeleton, such as a beetle, for example. Beetles, their skeletons on the outside, so it's an exoskeletal system. If energy is leaving the system, going outside the system, it is exothermic. And this, the suffix here, or the root here, the thermic part, thermic referring to heat or energy, and then the endo versus exo referring to whether heat is flowing into our system or out of our system, is how we get those terms. So the question, why is energy absorbed or released? So why is it that energy either is going into or out of our system? Well, this is because products and reactants, they have different amounts of energy. We can visualize this with some simple graphs. So say we have just a vertical graph. I shouldn't even call it so much a graph because I'm not going to put a horizontal axis on this. But if we have a visual representation of energy where, let's say, in one reaction, my reactants have this amount of energy and my products have this amount of energy. Notice as I go up here on my scale, my energy is increasing. That's why the arrow is pointed up. So if my products have more energy than my reactants, as I'm showing here, that means energy has to be absorbed, going from my reactants to products. If it's the other way around, if my reactants have more energy than my products, then energy has to be released to go from reactants to products. And so you can see here in this first example, with my products having more energy, this would be endothermic because I have to absorb energy to go from my reactants to products. If my reactants have more energy than products, then energy must be released to go from reactants to products, and that is exothermic. So on a very simple level, as far as understanding why energy has to be released or absorbed, it's simply because our reactants and products, they don't have the same amount of energy. Now why that is, we'll look at on the next slide in the next success criteria, but just on the most basic level, that would answer the question of why that's happening. So go ahead and pause the video and answer those complete the check for understanding questions on your note sheet, and play the video once you are done. Alright, so you've had a chance to answer those questions, and we'll look at those in class on the next day we're back in class together. So the question we want to ask now is, where does the energy come from and where does it go? Because this energy that we're talking about getting absorbed and released, it has to be responsible for something. It can't just disappear when it gets released. It can't just be absorbed and not be accounted for. And so what we're looking at now is this second success criteria. I can relate the terms endothermic and exothermic to bond formation and bond energy. So it comes down to this. The energy that is absorbed or released in a chemical reaction is a function of the bond energy of reactants and products. At first, that statement might seem a bit confusing or not clear or just maybe incomplete if we're not sure what this term bond energy is. But I think there's a very simple way of looking at this. It really comes down to this. Energy is required to hold atoms together in a bond. Just like with macroscopic things, anything that we would try to piece together or build, it takes energy to hold things together. And so let's just consider a very simple chemical reaction where we have a simple synthesis reaction where we have two atoms. I'll just represent them with a white atom and a black atom, and they undergo a synthesis reaction by running into each other. And we know they have to run into each other because of the collision theory. So if these two atoms run into each other with enough energy, and hey, there's that idea of energy again, then they will be able to form a bond, and that which I'm representing with this line here. And so these two atoms are now bonded together. Well, that takes energy. So whenever the bond forms, the bond formation, that energy has to get absorbed from the surroundings around the reaction. So if we look at that picture, that diagram we had from the previous slide, we have this scenario going on where we have the energy of our reactants down here, and then we have formed this bond here, and so we had to absorb energy. So whenever bonds form, those bonds, it takes energy. Energy has to be absorbed in order to get that to happen. And so we can see here that this would be an endothermic reaction because our products, there's more energy stored in the bonds than there are in the reactants. And so this is endothermic. If we have the opposite scenario, just flipping this reaction around, if we take this same molecule that we had as our product over here, and let's say we undergo a decomposition reaction where the bond is broken and now the atoms are separated, anytime the bond is broken, well, that energy that was holding the atoms together, it's getting released now. So we have this scenario here where because the bond is broken, that energy that was holding those atoms together is no longer there. That energy gets released. And so that's where that energy is coming from. Whenever we say a reaction is exothermic and energy is released, it's coming from the energy that was holding atoms together. Now, these two simple examples are just that. They're very, very simple. In some ways, I've oversimplified this a bit because there are all sorts of examples where we have endothermic or exothermic reactions when it's more than just a single bond being formed or a single bond being broken. But breaking it down like this, where we can see the formation of a bond requires absorbing energy to form that bond. The breaking of a bond, and it means energy is going to be released because that energy has to go somewhere, I think really simplifies it for us. So to summarize things here, in an exothermic reaction, remember that means energy is being released, the reactants have more bond energy than the products because that energy that gets released comes from the energy that is contained in the bonds of the reactants. In an endothermic reaction, the products have more bond energy than the reactants. The energy that's holding those atoms together is greater than of the reactants, and so energy has to be absorbed to get there. So pause the video and go ahead and complete the second check for understanding questions. So you've had a chance to do the check for understanding. Just summarizing and looking over our learning goal and success criteria here from this video. We have started to look at the role of energy in reactions. This is learning goal 6.1b. And our two success criteria for this lesson, I can define the terms endothermic and exothermic, and I can relate the terms endothermic and exothermic to bond formation and bond energy.